Hello and welcome to episode 10 of Climate Change Roundtable. Today, we will be discussing global climate models. A, what are they? B, how accurate are they? And C, why does the corporate media and the government love referencing them for either just, media stories or for new regulation? So joining me today for the discussion is Steve Milloy, who's new to the show. Steve, how are you?
It's great to be here.
Yeah, thanks for coming. And as always, Anthony Watts and Linnea Lueken. You all ready to get into it?
Oh, yeah.
Great. So let's just start off broad with this. So if people don't actually know what global climate models are, Anthony, I want you to just kind of describe to me and give me a sense of what are these climate models? Like what's going into them? How do they output temperature projections? How do they work?
Okay, well, before I describe climate models, I think it's important to describe what is climate. Climate is a abstract number. It's a fabrication of numbers. It's basically an average of weather over a period of time. The World Meteorological Organization defines climate as an average of weather over 30 years, high and low temperatures, things like that.
Mhm.
And so when they talk about the global temperature, it's an average of all the temperatures, high and low, around the world for a year, for example, or for a month, depending on which period. Climate is not something you can actually experience. It's a number. It's an abstract thing that's created by humans. And so if we didn't have this numerical system of creating this abstract number, we wouldn't actually know that climate is changing because the amount of temperature change is so small, about a degree or so, that you wouldn't be able to determine it by human experience for the most part. I mean, if you go into a room that's 68 degrees versus 69 degrees Fahrenheit, can people tell the difference? Generally, no. But that's the kind of small things that climate measurements are looking for. Now, climate models are an entirely different beast. Now, I've got a graphic here that shows kind of a globe and shows how the globe is partitioned. And the idea here is that we divide up the globe into all these tiny little sections, this grid of the globe, and they model the atmosphere in each one of these sections from the surface vertically upward. And they put in parameters such as solar heating, the amount of particulates in the air, the circulation, clouds, although clouds are not very well modeled in climate models. Scientists are the first to admit this. They really don't get clouds because clouds are so dynamic on a minute to minute and an hour to hour basis. So it's really hard to get the effect of clouds into the models and get it right. Dr. Roy Spencer once noted that just about a 2 to 4% change in clouds over the past 30 years would account for the kind of warming that we've seen. And nothing else would have to be in the climate models to account for that. So climate models basically aggregate all these different little partials of air around the globe in these grids, and then start from a starting point and then project into the future for temperature, precipitation, so forth and so on. The problem with climate models is that they're open-ended. They are not verifiable completely because if you forecast 50 years into the future, how do you verify it? With weather models, for example, which we're getting very, very good at, if you make a prediction about weather for next week, you know whether or not the forecast has become accurate or not. And then you can work on tuning the forecast model, the weather model, for more accuracy. And we've done that successfully over the past 30 years. And it used to be and then the biggest difference you can notice on TV stations now is we used to be able to give a 5-day forecast, and it was kind of dicey at the end of the 5 days, and then it was a 7-day forecast, and now it's up to 10 days in a lot of cases because the weather models are getting better. The climate models aren't necessarily getting better; they're actually getting worse because there's a lot of confirmation bias going into them. For example, the latest AR6 report that came from the ICCC said we're relying on RCP 8.5, which is a very specific climate model, and it's the worst case scenario. It's the one that says we're running off the rails in the future, temperature-wise. But the problem is that it's relying on the amount of carbon dioxide that is impossible to produce by burning basically all the fossil fuels on the planet. We still would not get to the level of carbon dioxide increase that this model is using. And so it's been discredited in scientific circles, but they're still using it because it's now a political tool.
Yeah, I mean, absolutely. Climate models are the thing that they do, and we'll get to this later. But they essentially report, data, and you think you're actually looking at real world numbers, but what you're actually looking at is projected numbers from climate models that are reported to you as if they're real life. I mean, they're
Right.
they're a tool that political elites use and that the media uses. This,
They are used to scare people. I mean, some of
yeah,
these projections are scary, and some people that don't have the wherewithal to figure out what's actually going on are actually genuinely afraid of the future because these climate model projections are being used as political tools and media tools, basically to say our future is bleak if we don't do something right now. The problem is that these are projections that are not verifiable.
yeah. I'm constantly hit with articles on the internet like. Scientists or doctors diagnose someone with climate change depression for the first time. And while obviously that's not a real thing, it's just a person that's freaking out needs to focus on their own life instead of what they hear in the news. Uh, they they're getting to a point where they are scaring people that much. But okay, moving forward. So I mean, we've been saying that these models aren't entirely accurate. Steve, I want to ask you, uh, how reliable are these models when we're projecting temperatures? A couple years down the line, past that, are these accurate at all?
Well, so far, and I think you have a graphic. Roy Spencer has done an analysis of 90 climate models, and they all run hot. They all overpredict the warming, and I'm not even quite sure they're very good at predicting, verifying the past, what we know happened. And like as Anthony says, they're just these unverifiable predictions
Hmm.
that run out into the future. We know they're wrong now. We have no reason to be right, or no reason to think they're going to be right later.
Yeah,
And the thing that upsets me the most about them is that models are passed off as to the public as science, and
yeah,
politicians call them science all the time. And of course, they're not science. I mean, they can be part of science. A model is used to make a prediction, but as Anthony pointed out, you have to verify the prediction, and that's the process of science, and that's what has never happened. And so far, they can't be verified, so they're not science. But
yeah.
a lot of the public, the UN, they're running around saying, "Oh, this is science. Science shows that we verified that in 2100 the temperature is going to be X," which is crazy. How can you verify something in the future?
Yeah, no, absolutely. And I want to show another graphic here that I pulled. And this shows, now this isn't the new climate model you were referencing, Anthony, but what this shows is how much these certain factors actually contribute to what the climate model reports. So you can see just in here that, for example, carbon dioxide in this model, which was from 2015, was 37% of how they, of like contributed to 30%, 37%, the word salad, to what the results actually were. And then you can see that clouds were 41%. But as you guys said, those are very hard to measure. And then finally, water vapor being 22%. But there's one
Yeah.
thing that's missing very clearly from this. The thing that warms us up when we go outside, it shines on you. You can't really look at it. It hurts your eyes. The sun, the sun, which we've been able to measure through solar flares, like how active it is, and how much it contributes to temperature rise. They don't
Well,
incorporate it in any way.
and some climate models do use sunlight. They use data from accumulated data from something called ESRI,
Yeah,
but for the most part, they don't have all the variables down. The amount of computing power that's required to do this is phenomenal because you have
yeah,
to divide up the world into these little small partials that I showed you on the globe, and you have to actually get finer than what we're doing now in order to get it right. And the problem is that the computing power doesn't exist. They've been making bigger and bigger computing centers. For example, there is a supercomputing center for climate modeling done by the National Center for Atmospheric Research, which is in Colorado at Boulder. But they put their supercomputing center in Wyoming. Why? Because the electricity is cheaper there because it's powered by coal. No,
yeah.
I'm not kidding. That's the truth. And they still haven't got it right. I mean, they're throwing lots of electricity and horsepower computing, at this, and they're still not getting it right. And they're still relying on some of the flawed assumptions, like with RCP 8.5. And, we just had this past week a case where models were being used to freak out everybody. It was about the North and South poles. And
Oh,
we did
yeah.
an article on that on climate realism, where the Washington Post ran an article saying that uh, they're flabbergasted about these unprecedented temperature spikes that have happened down at the South Pole and also at the North Pole. And if you scroll down there, you see
Yeah,
this
I'll go to the
graphic.
article.
Yeah, I see it. And so scroll down a little bit.
Yep, 1 second. All right, here we go. So here's the
There
actual
you go.
Washington Post
Here's
article.
the original Washington Post article. They're all freaked out because it's 70 degrees warmer than normal in Antarctica. And here's this graphic. Now, this is a model output. It's a weather model output, and it happens to be for one period of time. It's a forecast into the future for one period of time. Now, look at all that red over Antarctica. And then they talk about the 70 degrees. Well, the reality is when you measure the temperature on the surface, when we have another graphic here that I sent you that shows what the actual temperature was over the month of March.
Oh, got it.
And basically we're talking 70 degrees above normal, where you go from, like minus 80 degrees to minus 10 or minus 20 or something like that. You can see these numbers here. They're still well below freezing. But yet they're using red to indicate an anomaly, and that freaks people out. Like, Antarctica's on fire, it's melting. That's the kind of impression that is being put out by the media. But now let's go back to the climate realism article, and I will show you the difference between what a couple of days is. They get this one period of time where the model says, look, it's roasting. And then a couple of days later, wait, it's gone. What happened to it? Well, it's likely a numerical glitch in the model. Models are not perfect. Every once in a while, they get something in their input that causes them to go haywire. We see it with weather predictions all the time. So the top one, go to focus on the top one there.
Yep.
Okay, that's what it looks like now. Now scroll up just a little bit. And that's what it looked like before. So look at the red, where that's supposedly super hot, and then look at the other one below that, and now it's super cold just over a period of a couple of days. Models are not data. They are not fact. And so when you look at this and they fall apart, what can you conclude? The media isn't doing their jobs and fully investigating us. It takes people like us that just, we don't even have to hardly scratch the surface to figure this out. That's how bad the media is at reporting it. And the Washington Post and the editor there of their weather section, Jason Same should be ashamed for publishing this article because it basically inflamed and alarmed people for no good reason.
Yeah, and go for
just
it.
to add on to that, Anthony, there's a lot of scientists that ought to be shamed about all this too. It's not just the media. I mean, the media is largely ignorant of science, but there's a lot of so-called climate experts and modelers. They should be speaking up about this kind of stuff, but they don't.
Yeah, but they don't because, well, climate has become an industry unto itself, and you don't want to buck the industry.
Yeah. Now, there's one thing that you also found on this article, Anthony, that I want to point out to everyone. So let me just go ahead and bring it back. And this is something where they kind of hit it behind the scenes. So this is the Washington Post article, and they're reporting. I'm not showing it on screen yet. Here's the Washington Post article, and they're reporting all of these things as actual temperature. Or at least they don't make it clear that you're looking at models. And the only way you can find it out is if you actually click on the image, go to the next page, and then you look at this little subtext on the right side, simulation of temperature differences from normal centered over Antarctica from the American GFS model. So
it always pays to read the fine print, doesn't it?
And from your climate realism article, I knew that I had to go find the fine print, and I still couldn't find it for a while. I'm like looking under the graph. I didn't realize I had to click on it and then look on the sidebar. I mean, it's ridiculous what they're doing with this.
It's dishonest. It truly is. It's dishonest reporting.
Yes. Linnea, why do you think that, why do you think that they're referencing climate models over actual real world data? I mean, why does our government and our politicians love talking about climate models? Like, ooh, we need to hit the target set by the IPCC in the Paris Climate Accord.
Well, there's two reasons. One, the most obvious one is that real world data does not back up the alarmist claim. And that is simply the truth on every metric that they bring up, whether it's extreme weather or extreme temperature, whatever it is, drought, precipitation, snowfall, all of it.
Riots.
Yeah, all of it. The models, because they're not based in actual measurements, they can have them say any kind of extreme thing they want. They can push any kind of dependence on carbon dioxide. They can scare people with them. Real world observational data does not back it up. And because of that, what we were just talking about with how you need to dig to even know that it is a model. If you talk to a layperson who doesn't stare at this stuff every day and dig into it as much as we do, there are a lot of people who simply do not know that the models are not based on observed temperature or observed data. They do not know that these are computer fabrications of data. And because of that, you can show any kind of hockey stick chart or anything that you want, and people will take it as fact instead of as a hypothesis for the future. A bad hypothesis, because as Steve said, they can't even get them to match past temperature. They cannot get their models to replicate the past. So how are we supposed to believe them on future projections?
Absolutely. And I mean, the real value of this is if they use the real world data to try to pass overzealous climate regulation, people won't go for it when they're like, oh, the temperature's not really increasing like crazy, or CO2 is going up, and we're seeing a global greening. So instead, they rely on these models and they talk about what's happening 100 years in the future, and that makes it very abstract. And the more abstract it is, the less people will actually think through each step with. So you want to charge me you want to remake our entire economy for a problem we're having in 100 years, and you're not doing it based on real data. You're doing it based on equations that, when we look at this chart here, we can see are repeatedly wrong. These are all the climate models on the top. The black line going throughout the chart is the average of the climate models. And then below that, you actually have real world data with the green dotted line and the blue dotted line. So if you use the real world data, you're going to run into a wall where essentially it's innocuous. It's like, it's not something that people will be terrified about. So they have to continue to use these models. And actually, that brings up another thing, which I didn't get too much into in my preparation, but the people funding these, so these scientists put out this research that supports the global warming alarmism story. Now, who's paying these scientists? Why are they incentivized to put out research that supports this consensus? It's the government. If they don't play ball, if they don't produce, if they don't create their models to report high temperatures down the line, they won't get funded again.
Right. And there's also something called, Steve McIntyre brought this up years ago, what he calls the JorEl theory. Now, if you remember the story of Superman, JorEl put his infant son on the rocket to send him off of Krypton because Krypton was going to be destroyed. Okay. And the idea of saving the planet is very romantic and attractive to some of these scientists. Michael Mann in particular, Dr. Michael Mann, believes that he's truly saving the planet, and his actions are beyond reproach, even though he gets caught up in all sorts of fabrications and mistruths all the time.
Yeah.
But he believes that he is saving the planet. And so it becomes a matter of noble cause corruption. I'm saving the planet, therefore my actions, no matter how absurd or wrong, are validated. That's the problem we've got with some of these scientists.
Yes. Well, Anthony, I also think that regardless of how wrong the models are, these guys can never admit that because their reputations will just go poof.
Exactly.
And so we've got the institution is locked into these institutions are locked into these models. The government is, the scientists are, and it's really a case of the emperor's new clothes. I mean, one day someone will come along and they'll say, the emperor's not wearing anything, and finally people will believe it. I mean, we've been trying that for the last 20 or so or longer years. Haven't had a lot of success with the models because people still use them. But there's just, people have so much invested that it's going to be very tough to dislodge them.
It's become a form of identity for a lot of people that fighting this climate change fight. I mean, you get the Gretas of the world who create a global movement, and kids around the world are skipping. I think they're skipping school because they want to skip school, not because of climate. At least that's what I would have done. I would have been like, all right, go climate, or I guess bad climate change. I just want out of school. But a lot of people build their identity on social issues, and global warming is the issue that's supposed to kill us all. So it's very easy to have a savior complex over it and make that the social issue you care about most, which is, I'm essentially agreeing with you here, Steve. It becomes something that people will blindly accept, partially because they've blindly accepted. It's almost a chicken and egg, but they'll continue following it.
Yeah. Well, but your average person could give it up and and say, well, I believed it because supposedly reputable people. But people like Michael Mann and Al Gore and Gavin, they can never walk this stuff back.
Yeah.
Nope, they can't.
So-
They, as you say, their reputations would be destroyed, and their reputation among thinking people is already destroyed. I point out that there's a great book out that was published about a disgrace to the profession, and it was done by. Uh, I'm drawing a blank on the author. I know him well, but you know how it is. But it's a compilation of all his colleagues' comments about Dr. Michael Mann and what he's done and so forth. And it's called A Disgrace to the Profession. And it's just
Mark
a
Stein.
fantastic compilation of all of the mistruths and errors that have been going on.
Yeah.
Yeah.
And as long as we're on Michael Mann, I've got to say, so he's got all these black box models. The hockey stick, the hokey stick was a black box model. All these models, a lot of them black box. Michael Mann for a number of years was going around. He'd have speaking engagements, and he would pitch himself as a Nobel Prize winner, which he's not. And to my line of thinking, if you're going to lie about something that is that easily verified, imagine what's in the black box.
I'm just pulling up the Michael Mann chart real quick just to show how absurd it is when you actually look at real world data. Let's see here. Nope. This was the initial thing, at least in my lifetime, that set it all off. That, oh my gosh, look at these temperature projections. This is going to be runaway global warming. We're going to starve. We're going to burn to death. Now, climate models are definitely like a massive issue. I mean, there's use for models. It's just we shouldn't be basing future legislation on these models. That's
this is not a model, by the way.
No, this one's not.
Yeah, it's not a model.
But the other issue that I wanted to get into, and we're already at 22 minutes here, is why the surface temperature record is faulty. I know you've done a lot of research on this, Anthony, and anyone else, feel free to jump in. But when we're constantly getting the reports that, oh, it's the hottest year on record at here or here, you've done research showing that, like, oh, no, this isn't true due to the faulty stations. Could you briefly get into that for me?
Sure. Here's the bottom line. There's over the past century, America and the world has grown exponentially. We have added more population. We've added more infrastructure. Now, that infrastructure is consisting of things like concrete, asphalt, and energy utilizing devices, engines, air conditioners, tractors, trucks, cars, the whole thing. So our energy use has also soared, in addition to the fact that our infrastructure has increased. Now, here's the thing. Well, climate scientists value long-term records of temperature. They think that the long-term records are the ones that are the real telling ones. Well, there's a fantastic example, and I don't have it available here real quick, but I can tell you the story. The University of Arizona at Tucson is the perfect example of this. It was a land-grant university put together in the 1800s. They put, oh, there it is. Thank you. Now, they started out with a land-grant university, mostly agricultural based, and then it grew just like Tucson did and Phoenix did. And so more and more buildings got put up, and the campus kept getting more and more occupied, more roads, more buildings. And so in the final analysis, the temperature station, which used to be out in a field in a mostly agrarian campus, ended up in the parking lot. And this is the picture here on the left, that the station that they used to measure temperature and therefore climate, because it was a long-term station, ended up in the parking lot in front of the Atmospheric Sciences Department at the University of Tucson. Now, these scientists knew better, but they had no place left to put it because the campus kept getting absorbed by needing more and more buildings and infrastructure. So they put it in the parking lot. Now, I got to tell you, and anybody who's ever experienced a summer day where they have been out, in the sun, and then at nighttime, you stand next to a building and you can feel the heat radiating off of it. Okay, that's because the concrete or the asphalt or whatever it is, the bricks, have absorbed the sunlight and they are now re-radiating that as infrared at night. That keeps the local air temperature up. It elevates the nighttime temperature. And so what happens in the whole climate scheme of things is that because of this extra infrastructure, absorbing solar radiation, the nighttime temperatures have increased dramatically across the board throughout the United States and the world. We can show this. It's verifiable. And it's because of this infrastructure absorbing heat and re-releasing it at night. Las Vegas is a perfect example. For example, Las Vegas is built up over the last 50 years into just megapolis, right?
Yeah.
And so you end up with this urban heat island, which doesn't really make the highs much higher during the day, but it makes the nighttime lows so much higher.
Mm-hmm.
And because the nighttime lows are higher, when you average the high temperature and the low temperature for each day throughout the year, because the low temperature is elevated, the average goes up. And they use the average to predict the climate change. And that's the problem.
Yeah, absolutely. I got a chart here that shows the weather station, and this is on the bottom. You can see how they're rated, which I know you've done a lot of work with too, Anthony.
Right.
But you can see that the majority of these temperature stations, if they're red or orange for us colorblind people, that's not me, but I'm sure someone out here is. Well, I have nothing to say because I'm not.
Well,
colorblind.
the number is 82.5% of the stations we surveyed have some kind of problems associated with encroachment of infrastructure. And if you look at the trend comparisons, we did a study where you look at the stations that have not been impacted, the ones that are out in the boonies, like agricultural experiment stations in the middle of North Dakota and things like that. Those have a trend over the last 30 years of about 0.2, but the rest of them are much warmer. And that's the problem. They're mixing all these together to come up with a climate signal, and it's biased because of this. And there's actually peer-reviewed studies. The study that we started in 2009 with the Surface Station Project has turned into action on the part of science. They've published peer-reviewed studies that back up what we found. And yet science as a whole, climate science, is still not paying attention to it, and they're chasing these models still.
Yeah, I mean, go, Steve.
Anthony. Well, Anthony, don't you have? I think maybe you and several others as part of your project had a chart showing that I think 92.5% or something like that of U.S. temperature stations are not accurate within 1C.
Yeah, that's the pie chart that we developed. It's on surfacestations.org.
Okay.
But I mean, it's quite an error.
Yeah, it is.
It's quite an error when warming is supposed to be 1C.
Right. And the problem that we've got is that, here it is. The scientists that are climate scientists never get out in the field. These guys don't go and look at these things. And when we started showing how bad these temperature stations were, they freaked out, and they freaked out in a bad way. Rather than embracing what we found, they found ways to try to discredit what we found. And, we were actively maligned by NOAA. They actually shut down the list of stations when we were early on in the project to keep us from finding them. And we raised a legal challenge to them, and they backed off. But that's the kind of thing that they're doing there. They're trying to protect themselves. They can't walk it back. They don't want to look at the real data. They don't want to look at the problems. They just want to look at these projections of the future, because those are unassailable because they are unverifiable.
Yeah.
While I was doing research for this episode and Googling like temperature or global climate models observed over time related to real world data, if you do it on Google, all you get is the climate models are remarkably accurate. It's been great using them this whole time. You go to DuckDuckGo and it's like, oh no, these climate models, like they're all just like overestimating temperature forecasts.
And then I've got a question for you. You're very knowledgeable about the energy industry, the petroleum industry, and so forth. How much of an increase in consumption of petroleum to be converted as energy and therefore waste heat have we seen over the last 100 years? Do you have any kind of a number on that?
I don't have an exact number to pull up for you, but it's pretty significant. I mean, in 100 years, we've gone, or just slightly over 100 years, we've gone from horse and buggy to a spectacularly energy-driven system. So I can only imagine. I'm sure I can find that information pretty quick here if you give me a minute. But
sure.
It looks like
the
we're
point
getting
I'm
close
trying to make
time.
while you're looking for that is that waste heat is also a component. Waste heat, from combustion, be it industrial, power plants, automobiles, trucks, all these things produce waste heat. And that waste heat is also in part of our environment. And so that's a factor. But you don't see that in the climate models. They attribute a lot of this increase in temperature not to, infrastructure changes and the sun's, being stored in the infrastructure at night and being released, or waste heat, they look at carbon dioxide. They have a true belief that carbon dioxide is the only control knob,
Right.
and that's the only thing that we should be focusing on.
Right.
When in fact, climate is exceptionally complex. There's thousands of factors, literally, that change the way our temperature is, and yet they can't possibly touch all of these things, and they don't want to touch them.
Yeah, I mean,
Anthony, I think Roy Spencer has an analysis of the increase in U.S. temperature with population density, and population density, which he uses as a proxy for urban heat island effect, basically explains, the vast majority of the temperature increase.
Good point. You're right.
I'm pulling it up right now.
And population density in the U.S. has started to level off, whereas in the rest of the world, it continues to increase.
Yeah, so here we have warming in Celsius, and on the y-axis, and on the x-axis we have population density, and yeah, you can absolutely see just they're definitely correlated. I don't know if it's causation, but it's easy to make that inference that it is.
More people in a smaller area. That translates into more infrastructure, more buildings, more roads, etc. That translates into more energy use, and all of that translates into increased temperature at the surface.
Yeah. And then asphalt all over the place. That's a very good surface for holding a large amount of heat and then releasing it later. So yeah. It's this infrastructure that is the most powerful factor in creating these urban heat islands.
Yeah. Speaking of that, when I give talks, I like to talk about Chicago O'Hare Airport. Everybody here has flown through Chicago O'Hare Airport, right?
Yep.
Okay. The identifier that you get for your luggage tag when you go there, it says ORD, and that stands for Chicago O'Hare. Well, not really. It stands for the original airport that was there back in the 30s and 40s, which was called Orchard Field. Hence ORD. Well, gosh, you remember when Lindbergh, well, you weren't there to see it, but you've seen the films. Lindbergh took off from a grass field on his transatlantic flight. Aviation was based primarily in the 20s, 30s, and even into the 40s on grass fields, right? Chicago O'Hare started out as a grass field in an orchard field. Now it's this megaplex of concrete, and yet they still measure the temperature there. Thankfully, they don't use that in the climate models or anything like that. But the point is that the average temperature at O'Hare Airport has soared over the last several decades, partly due to the fact that it's this giant megaplex of concrete and asphalt now.
And planes, I mean, when those engines are running, they're just blasting heat, just a factor that you won't even get in cities. Linnea, you sent me the chart for global energy use. Let me pull that up real quick.
This is from the U.S. Energy Information Administration. So you can see,
it's a hockey stick.
Yeah.
Oh, just credit this. It's a hockey stick.
But look at that jump in coal even before the main portion of the Industrial Revolution and the use of motor vehicles. So it's a pretty nice hockey stick, if I do say so.
I assume that would be I'm not an expert on this, but I assume that would just be trains and that sort of thing, or maybe heating your homes. But,
trains and industrial use for smelting.
Yeah. But yeah, so we've seen the natural gas just really, I guess, explode over the years, petroleum explode, and nuclear is kind of turning down. That's a problem. If you climate is going to kill us all, people really want to solve the carbon dioxide issue, just go nuclear. And I don't mean metaphorically speaking, I mean literally speaking. But just to be clear, don't metaphorically go nuclear. Literally, I guess. All right, I'm done with my wordplay.
It's not working.
Hey, I thought it was good for the first couple seconds, and then I feel like I just talked myself into a corner and should have cut my losses while I was ahead. But so we're up here at the 34-minute mark. We should probably wrap it up soon. Do any of you have any comments you want to make right before we cut off here? Any last words?
Yeah, I think Anthony, don't you have an analysis on your website where you looked at rural temperatures, and they're a lot lower than what generally passes for temperature increase in the U.S.?
I'm looking for it.
While he's doing that, I want to say something about climate in general. Climate is a set of abstract numbers. Weather is what we experience on a day-to-day basis. And so, climate is not real. It's a fabrication of numbers, not necessarily untrue, but it's still something that you put together. You cannot feel or experience climate change. You can only experience weather.
Yeah. So this, let's see. This chart shows temperature changes.
Well, and Anthony, to your point, that's why they blame every weather event on climate now.
Right, I know.
Right?
They try to.
Yeah.
And for the people that can't sort it out, they believe this stuff.
Yeah. So they do feel climate change every time it rains.
While Andy's looking for that and trying to bring it up, I want to tell you a story about happened with my local city council about 2.5 years ago. They had to, one of the councilors had to leave because her business in downtown Chico got flooded by a thunderstorm that came through. Okay, a thunderstorm is a mile-wide event. It's not the whole planet. But one of the other counselors said, this is a perfect example of climate change, and it concerns me. And I've got children. And this is over a thunderstorm that came through and flooded the streets. I mean, mind-blowing. But that's how some of the politicians think.
I love that one of the commenters just mentioned the ClimateGate emails. I don't remember. I think we did call it ClimateGate, but where we learned that British scientists were suppressing actual data to support the narrative. Anthony, so I did a quick search here. Is this what we're looking for? It shows temperature changes in more rural and urban regions, or am I missing it here?
These are, well, you can see Atlanta very clearly there.
Yeah.
In the state of Georgia, and you can see Houston and Dallas and New York and Chicago. And these are basically where the temperatures have increased the most. And these are where we've got all the infrastructure and we've got all the waste heat and everything else. And so, but out in the boonies, well, look at those little tiny dots out in the boonies, the smaller cities and so forth.
Yeah.
Climate change is local in this graph.
It's targeting people now. It's targeting the urban areas.
Anthony, has anyone ever tried to quantify the waste heat anywhere?
There's a couple of studies that have, and but comparing that to temperature, I don't know yet. There's that's one of the topics that hasn't been fully investigated as far as I know. I mean, we know it to be true because we can see it, like that graph that we just showed you there, that map. It's there. Those are the places where energy is used intensely every day and where the infrastructure is concentrated every day. Should we be looking for long-term climate change there? I don't think so, because the signal is being swamped by the city itself.
Yeah. All right, we should probably wrap it up here. I was shooting for 30 minutes. We're at 37. So for those of you that are watching, thank you so much for joining us. The comment section was very active this time. I love to see it. Join us next week. For those of you that are new viewers, we're here every Friday at noon Central Time. Outside of that, anyone else? Final words for the audience? Do you want to just tell them how much you love them? No? Come on. All right, that would have been Sterling's thing.
They're all great.
Oh, we love you all so much. Unless if Jim's in there, then we don't love you. I'm kidding. All right, thanks you all for joining, and we will catch you next week.